Bonjour et bienvenue à tous à cette deuxième journée de l'Open World Forum 2011. Vous contribuez aujourd'hui au plus grand rassemblement sur l'open source en Europe. Hier, nous étions 700, aujourd'hui, nous serons certainement un petit peu plus. Et nous sommes réunis autour de ce phénomène qui nous concerne tous et tous les domaines, comme nous l'avons vu hier. Autour de la question de quel est le visage de l'open source aujourd'hui et quel sera-t-il demain. Donc pendant 3 jours, nous regardons l'open source à travers 3 angles, que sont Think, Code, Experiment, que vous avez vu dans votre programme, avec un format unique car il réunit tous les acteurs concernés, à savoir les décideurs, les développeurs et également les utilisateurs. Ce sera leur journée demain. Donc aujourd'hui, on accueille Code, c'est la journée qui s'ouvre. Dans la dimension Think, il y a 5 thématiques qui ont servi de fil conducteur tout au long de la journée, hier et aujourd'hui. Les 3 thématiques qui ont été abordées hier étaient Open Data, la neutralité du net et le cloud. Et aujourd'hui, nous allons ajouter 2 autres thématiques que sont le Common Knowledge et l'Internet des objets, qui touchent plus directement le grand public. Alors, dans quelques instants, je vais laisser la parole à notre premier intervenant. Et avant ça, je vous invite à éteindre vos portables. Nous vous proposons une traduction simultanée. Vous avez certainement vu les hôtesses à l'entrée. Donc, vous avez le code, le canal 1 qui est dédié au français et le canal 2 à l'anglais. Vous devez savoir également que l'événement est filmé. Donc, il se peut que vous apparaissiez sur les vidéos. Par définition, cette conférence est ouverte. Alors, nous sommes également en direct sur le web. Bienvenue à ceux qui nous rejoignent au-delà de cette salle. Et elle est naturellement aussi interactive. Donc, vous pouvez nous rejoindre sur Twitter, Open World Forum, et le hashtag c'est OWF11. Alors, le programme de la journée est dense. Nous avons 7 intervenants ce matin. Et puis 8 cet après-midi. Et le format est le même qu'hier, c'est-à-dire que nous avons une succession de présentations et de panels de discussion. Donc nous terminerons cette journée sur la clôture de Think et nous remettrons les awards pour Code dédiés aux développeurs. Alors à présent, je me tourne vers vous, notre premier intervenant. Je vous demande d'accueillir chaleureusement une figure de l'open source, un grand humaniste, au goût prononcé pour l'exploration et la conquête de nouveaux territoires. Il est fondateur à l'origine d'Ubuntu. Et pour ouvrir cette journée, il nous offre un voyage dans le temps avec une vision prospective de l'open source. Je vous demande d'accueillir Mark Shuttleworth.
Can you hear me at the back over there? Oh, that sounds good. There's something really delicious about coming to a city which is essentially timeless. Well, there goes the... Let me just go... Coming to a city which is essentially timeless to talk about the only thing which is constant in our industry, which is change. And my mandate this morning was to talk about the next 5 years on the client and in the cloud or in the data center. Now, 5 years is an extraordinary time. If we look back 5 years, we were in a very, very different world where very few of the topics which currently define the headlines in technology were even speculated about. So 5 years is a great distance to speculate about. Fortunately, that means we can keep it tight, we can keep it inspirational. And so really what I want to do is use the next 20 minutes to seed some ideas about fundamental changes that I think are likely to take place in the field of personal and enterprise computing. So Microsoft came out recently and presented Windows 8 very, very clearly as a platform for both tablet and desktop computing. And so they've essentially said that in their view, those two form factors converge into one device. My own perspective is that the level of convergence will go substantially further, that within 5 years, the average person will carry only one device, and that device will look just like a phone because it will be a phone, and it will run one platform, but have many, many faces. So fundamentally, on the client side, what we're looking at is a condensation, distillation of all of the functionality that the average person uses today into a single device, and the use of alternative docking form factors, essentially, to give you the experience of either a tablet or a desktop or a phone, depending on what you need to get done. How many of you have seen the Motorola Atrix, which was the first device, essentially, to be both a desktop and a telephone? Anybody here actually used one? So this is a device produced by Motorola, which they've struggled to describe. They call it a sort of a web book and telephone. But essentially, it gives you all of the benefits, the productivity benefits of a laptop. You dock it to a clamshell form factor that has an extra battery and an extra screen, and then you have the phone and the desktop, so you can work productively. It's built on Ubuntu, and other manufacturers are working on similar products. So we know that this is a form factor that's going to be more widely available. For phone manufacturers, this is very attractive because for the first time they have a real reason to put meaty horsepower into high-end smartphones. The CPUs of high-end smartphones today are perfectly capable of driving low-end desktop workloads, and more than capable for all of the things that we want to put on a phone. So the challenge for smartphone makers is how to create a demand for higher-end products in the smartphone audience. People can't tell the difference if you're just running it as a phone between a high-end processor and a mid-range processor anymore. So there's a real opportunity here for phone manufacturers. And there's a real opportunity for end users too, because the difference between having to carry multiple devices and carry a single device is phenomenal in terms of your lifestyle. Now these things always take longer to happen than you think they will, and then when they happen much faster. The key things that have to fall into place for this to become true, essentially, is that we need some sort of pervasive standard for the docking experience of this single form factor device. And I think that's going to shake out. Apple will have, obviously, their standard dock, but a standard will emerge for the rest of the industry as well. So this shift will have fundamental implications for us in the consumer Linux game, essentially. We're going to have to figure out how to make GNU Linux, standard GNU Linux, work really efficiently in mobile form factors. And that's going to be a substantial amount of work over the next year or two, but you'll see that as a real focus. In Ubuntu, we've been working very closely with ARM through a vehicle called Lenaro, and the focus of that has essentially been to make it possible for people to bring up on a mobile form factor, either Ubuntu or Android, very efficiently, very easily, to treat ARM much more like a standard PC environment, essentially. And to do that both from the perspective of mobile computing environments and also from the perspective of the server. We talk a lot these days about something called Ubuntu Core, which is essentially all the heart of Ubuntu, the engine room of Ubuntu. Essentially Debian, but on the Ubuntu timescale with the Ubuntu release cadence and support commitments as an underlying basis for all sorts of different products that people are building. I think there's a real need for an industry standard core. I don't believe that will come from a consortium, but I do think it could come from something like Ubuntu Core, which is royalty-free, which is already enabled and tested and certified on many of these platforms, and which has all of the sort of generic components and pieces that people need to build their own custom user experiences on. So that's going to be an important challenge for us. In terms of the actual consumer experience, I think the fundamental shift that we'll see over the next 5 years is related to connectivity and the personal cloud. The idea that your device will be perfectly backed up all the time, that you will essentially have all of your data simultaneously accessible from your one personal device, but then from any other device via the cloud as well, using a combination of streaming and caching and replication. Now, there are some fundamental questions there, for example. Will all of that data live at Google, and all of the privacy and jurisdictional questions that raises? Or will it essentially be a distributed data infrastructure with the end user having more control over that? There's some fundamental challenges and questions there. In Ubuntu, a key focus for us has been Ubuntu One, which is a framework for online services delivered straight to the desktop. There are services now which cover music, the ability to sort of buy and store and share music, music streaming, general file replication, syncing, and storage. What's really important for us there is cross-platform capabilities, so the ability to deliver your files to Windows, your files to Android or iOS, your files to the web, so that you genuinely have the ability to have a common content pool across all platforms and across all devices. And on the corporate front, I think we really are seeing Windows getting squeezed into a very uncomfortable position. Today, most corporate IT managers are thinking about Windows as a service, Windows as a capability that they can deliver to any screen, regardless of the underlying platform of that screen. And I think that's a very healthy situation. The reality is there's a great deal of value to enterprises in their historical Windows deployments and in the practices and application richness that they have from that environment. But there are also real challenges for them in the management of that environment and in its susceptibility to malware. So thinking of Windows applications as a service that you can deliver allows you to take the right platform choice for a particular profile of user and still have the flexibility to deliver applications to them from any underlying platform. So we see a great deal of innovation in this space today, a really marked increase in the willingness of enterprises to explore alternative platforms on the desktop. Some of those are straightforward migrations. There are some very large businesses now that have found that it was fairly easy to move 10% of their workforce. So if you have 50,000 desktops, moving 5,000 desktops is a savings that essentially mitigates the increased cost of some of the new Windows licensing schemes. So large organizations typically easily move 10% of their desktops. We see some organizations moving 80 or 90, but mostly it's organizations taking a sort of an easy bite of about 10% of their desktops to an open platform like Ubuntu, and then finding opportunities to grow based on that. So on the server front, I think what we're in right now is very much like the early days of the web. So the web, around about 1995, there were network services that were fairly well established, and then the web came along, and slowly the web consumed all the other services. Today, if you're thinking of creating a new service, you will typically build it on top of HTTP as a standard protocol, even though HTTP has all sorts of sort of fairly hard design constraints that don't necessarily make it the easiest protocol to support for a particular kind of service. It's so widely deployed, so well understood, so rounded now that you can essentially model any other protocol on top of HTTP. So we see, old protocols like SMTP getting eliminated in favor fundamentally of HTTP. And that was a transition that's taken 15 years and will take 20 years really to fully complete. But today we're at the same early portion of the curve with a similar kind of movement, and that movement is to elastic cloud infrastructure. Now, the term cloud is being slapped on all sorts of different things. If you don't know what else to say about your product, call it a cloud product and hope for the best. But what's really going on is this shift to an abstraction layer for infrastructure. When the dust settles, I think we'll see a very clear pattern emerging. And my perspective is that in 5 years' time, most people, when they're deploying new capacity, will deploy it in an elastic fashion. So compute, storage, network will essentially be treated as bulk commodities, whether that's internal to an organization or external to an organization. Now, a lot of people, there's a great debate at the moment between the relative advantages of platform as a service, where essentially you write your applications in an environment which is inherently scalable, versus infrastructure as a service, where you still essentially think of it as, to a certain extent, generic raw material infrastructure that you have to shape, in a virtual machine. And these two, have benefits. Each have relative benefits. To me, it's very clear that infrastructure as a service will win in the sense that everybody will do infrastructure as a service. This will be completely ubiquitous, just as everybody has HTTP in their network today, whether it's internal to the company, external to the company, between companies. HTTP is the lingua franca. In the same way, standardized infrastructure as a service will be the baseline of all compute raw materials. Platform as a service will certainly thrive, I think, but it'll thrive as a service on top of the infrastructure, the elastic infrastructure that people will provide. I don't believe that any of the single provider platforms as a service, like Google App Engine and so on, will gain real traction, simply because they don't address the legacy story well enough. It's just not possible to think to start, taking your legacy applications into that environment. Whereas it really is possible to start migrating legacy applications into the infrastructure as a service type environment. So to me, it's very clear that infrastructure as a service will be the common foundational layer. It's also very clear that that will be built on open source, for the simple reason that every major network infrastructure platform for the last 20 years has been essentially pioneered, led, and standardized around open source reference implementations. There will be proprietary stories in there. I'm sure Microsoft will have an infrastructure as a service product, and other vendors will too. But in order to survive, they will have to speak some sort of standardized infrastructure as a service protocol, just as they have to speak HTTP today. The leading candidate in my mind for that kind of Apache of the cloud role, the reference implementation, is OpenStack. It's not a settled question by any means, but I think the leading candidate is OpenStack, and it's that for a number of reasons. First, if you look at the underlying motivations of the people driving it, it's easy to believe that they all have an interest in a high-quality, open-source, level playing field infrastructure with the costs equally borne across that audience. All of the telcos and public and specialist cloud providers have a shared interest in the existence of that. They also all are equally weak in the sense that if they try to diverge too much from that, they're competing with everybody else who's diverging from that. None of them has a sort of strong center of gravity. So in that world, typically, you tend to find a strong center of gravity forming. I think that's likely to form around OpenStack. There are, of course, real challenges. When a project has as much mind share as early as OpenStack does, it can spin out of control because too many people want too much from it. And I think the key question there is whether they're able to maintain crisp, clean, clear leadership and focus in an environment where too many different institutions are essentially banking on it representing their particular needs. I expect and hope to see some sort of official standardization process. I think that will happen around something that looks roughly like the AWS model today. Not necessarily the exact same API, but certainly the conceptual model. Just as there are multiple implementations of HTTP, there will be multiple implementations of that standard API. And in order to gain real traction, it's going to need to be something close to the current gravity well, which truly is AWS. In terms of virtualization, I think there are two stories that really matter. One is KVM, which is a true virtualization story. First, I think the first major distro to ship it was Ubuntu. It's now fairly widely supported, and I think it will become the sort of standard virtualization platform of the open source environment. I think one of the key challenges for AWS, of course, is that they predate that kind of clarity. The other platform that I think is going to be very important is something called LXC, which is a containerization effort. Now, containers look like virtual machines, but they don't have quite the same level of separation between them. So they're appropriate in environments where you're willing to trade isolation for performance. So say you are a department in a bank, and you want to think of your infrastructure like a cloud. You want to manage your financial computation infrastructure like a cloud, but you don't need. You essentially, each workload trusts every other workload to a certain extent. All the same people have permissions to all of those workloads. In that kind of environment, you might choose LXC because it gives you a marked additional performance. So it's lighter weight, essentially. You can run more workloads on the same physical hardware. And that trade-off of performance for isolation makes sense. So we've done a lot of work in this latest cycle, for example, on making OpenStack work with LXC, so that you can use OpenStack to address a network of machines, and those machines don't all have to support the hardware virtualization primitives of KVM, and you get the extra juice, the extra kick out of the hardware that you've paid dearly for. Another key technology I think that we'll see in that universe is VMware's Cloud Foundry. Now, VMware is obviously a kingmaker to a certain extent in the virtualization game, and they face this very challenging transition into a cloud world. But Cloud Foundry is, I think, a very savvy move. Essentially, it's a generic harness for platform as a service built on top of infrastructure as a service. So it's a bridging layer between platform as or infrastructure as a service and platform as a service. It allows you to take a language environment that you want to access, like a PaaS, and it lets you. Well, there's still always hard work to be done. It essentially generalizes the underlying scalability issue, and so if you have, a platform like Django that you're interested in, it gives you a standardized way to think about the elasticity of the underlying pieces. And if you then address the elasticity story of Django itself, you can then have Django as a platform as a service. So I think Cloud Foundry is going to be an accelerant in that world of sort of mushrooming options in the platform as a service game. You can today take Ubuntu with OpenStack, with Cloud Foundry, with any of the current supported Cloud Foundry languages, and then you have, at very low cost and with very high efficiency, you have an elastic cloud infrastructure with any number of different platforms as service accessible, as well as the ability to map legacy workloads into that cloud in a very easy, very efficient manner. Efficiency is a key story, I think. So ARM is going to be a really important competitive force in the data center. Whether or not there's a huge swing towards ARM, or whether it essentially just sets the agenda for the next 5 years, competitive forces will tell. But we've seen a real dramatic surge in interest in ARM in the data center, ARM on the server. Ubuntu 11.10, due out this month, next month, is the first widely released operating system that will support ARM as a first-class citizen for our server edition. And there's a new generation of ARM hardware coming to market, which has been designed from the ground up for server-type environments. So there's going to be a great deal of innovation there, a great deal of competition and change. But we're certainly going to see that, I think, setting the pace for power density or performance density. One of the things that we're doing a lot of at the moment is building clouds for people, or helping people build clouds. Large hardware providers think that in future it might be worth their while not to sell their hardware, but to rent their hardware, or to make their hardware available for rent. So they're all building public clouds, and we're engaged with a good number of them, building out their public cloud offerings. Telcos are saying, well, not only am I going to put a connection down to your premises, but I'll give you the ability to burst your infrastructure needs onto our centralized infrastructure network, so you can build hybrid clouds. And we're engaged with a number of telcos, helping them build clouds on Ubuntu and on OpenStack. So we're starting to really understand some of the key changes and trade-offs that happen when you dive into that kind of environment and what you want to achieve from that kind of transition. And one of the key things really is human scalability. We talk about software scalability all the time, but one of the key changes really is human scalability. How do we essentially scale up the reach and effectiveness of the people who are responsible for that infrastructure. And this is a continuation of a theme that we've had for the last sort of 5 years, where operations essentially became much more of an engineering and development exercise than a traditional maintenance type, deployment type exercise. In many of the sort of world's most familiar brands, the ratio of human beings to servers has gone up to 10 or 20 times what it used to be before the Facebook and Google era. So it's becoming really important to sort of think about how many different machines can one person be responsible for. And in the sort of data centers of the future, those ratios are extraordinary, you know, one person to 10,000 machines or higher. In flat type infrastructures, like you can imagine the Google or Facebook infrastructure as being, you know, relatively flat, it's easy to understand that. What's more interesting is to look at a richer, more complex infrastructure, like a typical enterprise IT infrastructure, where you literally have hundreds of different applications that aren't on the sort of flat substrate, and you wonder how you're going to increase the sort of human scalability factor there. Well, in the past, we've seen a lot of work in things like configuration management tools. Puppet will be familiar to people, Chef as a new sort of entrant in that game. Essentially, you can think of those as kind of like extending the arms of your servers, of your system administrators. They still have to think and do all the same sorts of things that they used to have to think and do. It's just that they can now efficiently do it and sort of spray it across more machines. So they can say, right, make this change to this configuration file on all of our machines or on those 10,000 machines over there. So it's kind of like a lever to expand the reach of your system administration or ops team. We've also seen a trend towards thinking about ops as an engineering exercise called DevOps. It's really about defining the language that developers and operations speak more clearly and thinking differently about the handover process. And it's that really led us to some work that we've driven recently, which I think is probably the most exciting stuff coming out of Canonical and the Ubuntu community around the cloud. The key issue that we identified with those sort of the configuration management approach is that you still suffer ultimately from a certain amount of central planning. You still need in somebody's head a master map of what is where. And so like any sort of large economy that's being centrally planned, it's very difficult to get the inefficiencies out of that environment because it depends ultimately on someone or some system being able to keep in its head, you know, all of the complexity. So for example, if you've got a change that you want to make, someone has to know where that change is going to impact. And it's sort of a reversed dependency problem, what depends on what. And it's a very difficult problem to solve, and it's a very difficult problem to scale. Humans do very well at that, up to a certain point, and then very badly after that. And so when you look at the operations practice, a lot of it is dealing with this fundamental problem. It's a problem that configuration management doesn't really address because it's not about efficiently getting that change to 10,000 machines. It's about knowing which 10,000 machines need that change, and if you made a change, which other 10,000 machines are going to be, you know, impacted by that. So that's led us to a different way of thinking about service deployment. At an infrastructure level, I think things stay essentially physical. People still will think about compute and network and storage at the infrastructure level. Above that, however, the mental model shifts and it becomes more service and platform as a service like. And the key thing about infrastructure as a service is that it provides a very clean separation between those layers. It lets you build a team that just worries about infrastructure and lets your operations team start to think in a much more abstract way about the services that they're providing. One of the key drivers for us was this idea of scaling change management, that you should have to scale your system administration team by the number of decisions you want to take, not by the number of places you have to implement those decisions. And that's a fundamentally different way of thinking about it. And so what that means is that you essentially need to be able to isolate every decision and make a decision and execute a decision with confidence, with the system taking care of the deployment or the execution of that decision. So service orchestration essentially blurs the lines between infrastructure and platform as a service. It lets you think about every component as a service. It lets you think about the scalability of a particular service inside that service. It really encapsulates the scalability of services. The tool that I'm describing here, so we think of it as magic for the cloud. So the name that we use for it is Juju, which in the same languages that Ubuntu comes from means language. Ubuntu means humans, humanity, the essence of being human, and Juju means sort of the supernatural and magic in those same languages. So magic for the cloud. Somebody described it to me as the same sort of shift in thinking that we got, again in the mid-90s, when people moved from auto-build, auto-configuration type tools to package management. Instead of trying to make your software build more effectively on multiple different platforms, you define the relationship between the platform and the software. So in a package type environment, each piece of software knows what it depends on. Each piece of software knows what configuration it needs. And when you say, I want to install this piece of software, it pulls in all of the other pieces that you need. So Juju's platform agnostic. You can deploy on AWS. You can deploy on the Metal. You can deploy on your workstation with LXC, any kind of underlying substructure. And it gives you a level of service encapsulation that for many people who find the cloud sort of difficult to manage, brings a level of clarity to their conversation between the developers of those services and the ops of those services. It's for me, it's a little bit, the excitement around that is a little bit like the early excitement I remember around Debian and RPM as that packaging story started to emerge in the Linux world. So I hope that serves as some sort of catalyst for thought and debate during the rest of the day and tomorrow. And again, it's a delight to be here. As I said, in the next 5 years, everything will change, except for the beauty of Paris. Stay well.
Thank you very much.